All right, so in this video, we are going to wrap up section 2.3. We're going to talk a little bit more about the equations of lines and focus more on the types of slopes that are positive and negative, and not so much the special slopes of zero and undefined. So when you don't have a slope of zero or undefined, and instead you are working with a positive slope or a negative slope, there are three different ways you can actually write the equations of lines. That's why I put them in a separate video. The first type of line that you want to be able to do is called point slope form. And so point slope form will follow this formula, which is y minus y1 is equal to m times x minus x1. And in order to do this equation, the two things that you will have to know are, first, you must know the slope of the line, and secondly, you need to know at least one point that falls on the line. And if you know those three values, you can plug them into this form, and that will be your point slope form answer. The second type of line, and probably the most popular that we'll see going forward, is slope-intercept form. So slope-intercept form has the form y equals mx plus b, where in this form, m is still your slope, but the b value that you see in the problem is actually your y-intercept. And so if you can get it into this form, you would know the slope and the y-intercept directly. Lastly, the form of line we're going to look at is called the standard form of a line. And so standard form of a line looks a little bit weird. It has the form ax plus by equals c. And from this, none of the numbers you see are actually a giveaway for anything, but we're going to talk a little bit more about standard form on the next slide. One other thing that I will note here while we're on this slide is that typically you will have to find 2 or 3 of these on each of the problems we're about to do. Now, one thing to also note here is that typically we don't write slope-intercept or standard form directly, because usually you're not given enough information to go directly to both of those. So one thing to note here is that if you were ever trying to find slope-intercept or standard form and they don't give you enough information, we will typically take our point slope form, which usually you have enough information for that one, and we will convert it either into slope-intercept form or we will convert it into standard form, but usually that's going to be our starting point. Point slope form can be easily transformed into the other forms of the lines. Now, a little bit more about standard forms, because that one doesn't really tell us anything. Remember, the standard form of a line is ax plus by equals c. Now, in this form, there are a couple of restrictions. The first one is all of your coefficients need to be integers. And so the easy way to think of that is there should not be any fractions in your standard form of a line. The a value, the b value, and the c value should all be whole numbers, either positive or negative, except for one, which leads me to part number 2. Part number 2 says the leading coefficient a must be a positive number. So while, yes, you need whole numbers, the extra restriction here is on a. You don't want a to be a negative number. If it's negative, we'll have to fix that. While b and c can be negative, just the a value you have to make sure is positive. Now, one other note here at the bottom is if you are ever given the standard form of a line, remember, you can't actually see slope directly from this form, so we have an equation to help you with that. If you're trying to find the slope of a line given in standard form, you will use the formula m equals negative a over b. So once again, that formula for slope only works if you're in standard form. We don't use it any other time. We go back to the other slope formulas that we saw in the previous video to this section. All right, so let's do some examples with this new idea. So number 1, I would like you to find the indicated forms of the line with the given slope that passes through the indicated point. So on number 1, I've given you a slope of -4/3 and a point of 3/8. And I want you to write the equation in point slope form and slope intercept form. So let's start with point slope form. The formula I gave y'all a little bit earlier was y minus y1 equals m times x minus x1. Now, in the original problem, obviously you can see that your slope is labeled, and then your point, the 3/8, is going to be our point x1, y1. We're going to plug those three numbers into our point slope form. So that would be y minus 8 equals my slope of -4/3 times x minus 3. And so there is your answer to part A. That is the point slope form of a line. Now, for part B, they're asking us to solve this in slope intercept form. Now, slope intercept form means you have to get your answer into the form y equals mx plus b. Now, one of the easiest ways to do this is we are going to take our point slope form that we just found in part A, and you are going to solve for y. So you want to try to get this y value by itself if possible. So let's see if we can do that. So we're going to have y minus 8 equals, we're going to take this -4/3 and distribute it. So that would be -4/3 times x minus, minus 4/3 times -3. So what ends up happening here is you end up with y minus 8 equals -4/3 x, and two things actually happen here. First of all, your 3's cancel, and you're left with a -4 and a negative, which will make this a +4. And so, like I said, you're trying to get y by itself. So one more thing you have to do, we're going to add 8 to both sides. Let me use a different color here so it's easier. +8 + 8. And you will end up with an answer of y equals -4/3 x plus 12. That is your slope intercept form of a line, because you notice that it has y equals a number times x plus the b value that you end up needing. All right? And so that's how you can find point slope and slope intercept from a point and a slope. All right, let's do a very similar question. It says, once again, find the indicated forms of the line that pass through the points that are given. So this time I did not give you a slope and 1 point. I gave you 2 points that you have to work with. So we have the point -3, 6 and 3, -4. And I want you to find the point slope form and the standard form of your line. Now, the one issue is that, if you remember from the last slide, in order to do point slope form, you need to know 1 point and you need to know the slope. Well, we've got 2 points, so we can pick whichever one we want, but we don't know what the slope of the line is yet. And so if you go back to the previous video or the first half of section 2.3, I gave y'all a formula to find the slope between 2 points. And it was m equals y2 minus y1 divided by x2 minus x1. So similar to the last video, I'm going to let my first point be x1, y1, and I'm going to let my second point be x2, y2, and I'm going to plug them into my slope formula and calculate it. So you should end up, if I plug the 4 numbers in order, -4 minus 6 divided by 3 minus -3. Well, -4 minus 6 is going to be -10, and 3 minus a -3 is going to be 6. Both of those numbers share a 2 in common, so we're going to simplify our slope here. And so if I divide both of those numbers by 2, you should simplify this into -5/3. Now that I know what my slope is, and I've already labeled my points appropriately, I can now go ahead and find my point slope form. So we've got our x1, y1, and we have our m, so let's plug them in. So that would be y minus y1, or y minus 6, equals our slope of negative 5/3 times x minus my x1, which is negative 3. Now, one thing we don't want to leave in our point slope form is we never want to leave a double negative. So this will be y minus 6 equals negative 5/3, and a double negative just becomes positive. And that is going to end up being your point slope form. Now, from there, we now need to convert this into standard form. So remember, standard form has the form ax plus by equals c. So instead of trying to solve for y directly, you're trying to simplify your point slope form into the x's and y's on one side and the number on the other. So we're going to start this very similarly to how we did the last one. We're going to take the slope of negative 5/3, and I'm going to distribute that. And so when I do that, you get y minus 6 equals negative 5/3 x minus 5/3 times positive 3. Well, very nicely, it looks like the 3's are going to end up canceling here, and you get y minus 6 equals negative 5/3 x and then minus 5. Now, if you're trying to match this to standard form, as you can see, you're trying to put your x's and y's on one side and you're trying to put the numbers on the other. So in order to achieve that, I'm going to move my x value over, which is the 5/3 x, by adding it to both sides. So that will give me the 5/3 x that I need. And I can also bring down the positive y because it's going to stay there. And to move my constants over, I'm going to add 6 to both sides. That way it cancels off the left, and you end up getting negative 5 plus 6, which is positive 1 on the right. Your last thing you want to do here is remember there is a rule with standard form that the values in front of x must be a whole number. And right now you've got a fraction that you have to work with. So we have to get rid of that fraction, and the simplest way to do that is you want to multiply by the common denominator. We saw this back in our chapter 1 videos in the past. So since your only denominator here is 3, I'm going to multiply everything in my standard form by 3 to ensure that the fraction goes away. So that would come out to be 3 times 5/3 x plus 3 times y equals 3. And what you will notice happens is your 3 divided by 3 cancels, and you end up with 5x plus 3y equals 3. And that is the standard form of your line. And so a little bit more work to do the standard form, but that's the process you have to go through to get from point slope to standard form. All right, and so to wrap up this video, I have a couple more slides of kind of random questions a little bit, but we want to make sure we kind of tie everything together to wrap up our lines discussion. So on number 3, given that 3x plus 4y equals 12, which as you can tell is standard form, I want you to find the slope and the y-intercept and then use that to graph your equation. So if you remember earlier, I gave y'all a formula to find slope if you are given standard form. So if I scroll back up real quick, hopefully you jotted it down. Remember, slope of standard form can be found by doing negative a over b. So instead of having to go through some other way of finding this, we have a direct relationship to find the slope of a line. Now remember, in standard form, your a and your b value are the two numbers in front of the x and the y. So this is going to end up being negative of your A, which is 3, divided by your B, which is 4. So we have a slope of negative 3/4. Now, as far as the y-intercept goes, we have to go back to our definition of y-intercept, which is that x is equal to 0. So if I use the original equation and let x be 0, this would be 3 times 0 plus 4y equals 12, which the 3 times 0 just goes away. And so if you're left with 4y equals 12, we can divide both sides by 4, and y would end up equaling 3. So now that you have the slope and the y-intercept, we can find and graph the equation of this line. All right, so since the y-intercept is 3, I know that my graph has to cross the y-axis at positive 3. And remember, for your slope, when you're going to the graphing part, you're going to use rise over run to help you. So for rise over run, our rise would be negative 3. So we would go down 3 units. And then your run is 4. So you would go to the right 4. 1, 2, 3, 4. And that's where you would plot your second point. And then you can play connect the dots. And that is the line that's represented by 3x plus 4y equals 12. And so a little bit different in order doing it from standard form, but it is something that you got to be able to do for your assignments. All right, and so last but not least, we kind of did this problem in the past, but I wanted to bring it back just so we have this big connection here. I want you to sketch this final line by doing just the intercepts. So in the last problem, I gave you a standard form where you found the slope and one of the intercepts and it worked. But instead of finding slope, another way to graph lines is just find both intercepts. So what I'm going to do here is I'm going to find the x-intercept and the y-intercept. So from our previous definitions and past videos, we know that the x-intercept means y has to equal 0. So if I let y be 0, in my original problem, we know that the zeros will end up canceling. And if you divide both sides by 4, you will get x is equal to 6/4. All right. And what you should know is that both of those share a 2 in common. And so if you divide both of those by 2, you get 3/2. So we have an x-intercept at 3/2 0. For the y-intercept, just like we just saw in the last one, to find that, you need to let your x value be 0, which will make this 4 times 0 minus 3y equals 6, which once again, the 4 times the 0 is going to go away, and we can divide both sides by negative 3, and that will give us y equals negative 2. So we end up having a y-intercept of 0, negative 2. If you plot both of these points on your graph, so if I go to 0, negative 2, which is the y-intercept, and then 3/2 is the same thing as 1.5, so we go to 1.50, you can see once again, that's enough information to help you graph your line, and we didn't even need to find the slope of the line in order to draw it. So in this video, we kind of went through the idea of what happens when you have positive slope and negative slope. How do you graph those lines? How do you find those lines? We did point slope form, slope intercept form, and standard form throughout this video. So that wraps up section 2.3. In the next few videos, we're going to move into section 2.4 and talk about the idea of parallel and perpendicular lines.